Okay, so in the previous lesson, we were able to look at momentum and impulse. And today I go on a little bit further with questions on momentum and impulse. Just to remind you, Revolutionary Science Workbook Study Guide 1 by Norman Muvoti and Timothy Sibeko are some of the textbooks that we can make reference to in connection with aspects of momentum and impulse. I remember telling you that impulse is the product of the net force acting on an object and the time the net force acts on an object. And we explained that impulse, its effects in safety, as in safety belts, arrestor beds, the crumpling zone of a car, as well as airbags, and an all-important equation that says F net multiplied by change in time is equal to mass times the change in velocity, which is basically the change in impulse. So you can actually replace that m times delta v with p multiplied by m. All right, or m multiplied by p. Okay, still the same change in p, sorry. Change in momentum. Okay, so that's what impulse is all about. Let's move on a little bit further. I went on to explain elastic, or maybe something new that we can take a look at today, is elastic and inelastic collision. Elastic collision is a collision during which kinetic energy is conserved. I'm sure from the previous grades, you were able to calculate kinetic energy, simply known as EK, is equal to half mv squared. So in a situation where there is elastic collision, we are saying the kinetic energy is conserved. In other words, kinetic energy before is equal to kinetic energy after. So I'll put it here, EK before being equal to EK after. After what? After the collision. And in an inelastic collision, the EK before is not equal to the EK after. Very important for us to think about when we are talking about elastic and inelastic collision. All right, let's move on to the next slide where I've got a question. I always like it when we disentangle ourselves from the other things that we're looking at. You might have been doing maths in the previous hour or 2 hours or doing another subject, and now you want to get into the science, physical science spirit. So one way to do it is to start off with a concept on physical science, a question that you need to think deeply about. Which quantity is equal to the rate of change of momentum? Which quantity is equal to the rate of change of momentum? Do you remember? Is it mass? I think we explained what mass is. It can be mass. Is it impulse? I think I've just told you what impulse is. It can be impulse. Acceleration is the rate of change of velocity. Therefore, our answer is C. So formulas do tell us a story about a particular concept, like F net being equal to rate of change of momentum, which we know is almost the same equation that we use when we are finding the change in momentum, which is impulse. So that's just something for us to quickly think about as we revised question. Do you want another question? Let's look at another question quickly, just to remove cobwebs from our heads and to remind us of what we have looked at. Trolleys, two trolleys, X and Y, of masses M and 2M respectively, are held together by a compressed spring, and then that spring between them falls off. I think you've been familiar or must be familiar with this question. We've done a question like this before. Now, the spring is now released and it falls to the ground, while the trolleys move apart from each other. Obviously, the magnitude of momentum of trolley X is going to, we are talking about the momentum. Now, questions often require us to remember the laws, principles, or concepts that we have learned, especially when they are multiple choice questions. Momentum, 0? No, it can be 0. Half the momentum of the magnitude of momentum of the trolley Y? No. If I am to apply the law of conservation of momentum, you can agree with me that the best answer here is D, the same as the magnitude of the momentum of trolley Y. Why? Because of the law of conservation of momentum. We are moving on with questions. Ball P and Q of the same mass are dropped onto a concrete floor. Both balls hit the concrete floor at the same speed, v. Ball P rebounds with the same vertical velocity, v, but ball Q rebounds with a speed that is half v. Refer to the diagram while ignoring the air resistance. Which one of the following systems regarding the collision of each ball with the concrete floor is correct? Look at the answers. Read them. Which one makes sense to you? According to the laws, according to the principles, according to the equations that we have looked at. Did you say the answer is B? Yes, you're right. The change in momentum of ball P. Remember, these two balls are not colliding with each other. If they were colliding with each other, the change in momentum would have been the same if it was in an isolated system. But in this instance, they are colliding with the floor. This one bounces off at the same velocity as it hit the ground with, and that one bounces off with half v of the velocity that it hit the ground with. So in this case, the change in momentum of the first ball is more than the change in momentum of the second ball. All right, let's look at longer questions now. There's a part on this question that's not clear, but let me read it off so that you know what's going on. It says a 2 kg block is at rest on a smooth surface that is frictionless, horizontal surface of length x. So we've got a 2 kg block. All right. It rests on a smooth surface, which means the surface is frictionless, okay, right? And that block is called block X, all right? And the length of that block is X, sorry, it should read the length of block is X, so a length of block is X. Apologies for technology that has played with me this morning. All right, so the length of this block is X as shown. Now a bullet of mass 0.015 kg traveling east at 400 meters per second strikes the block, and passes straight through it with constant acceleration. Refer to the diagram below. Ignore the loss of mass of the bullet and the block. So what is happening? Understand that before, the block is moving 400 meters per second, right? The bullet 400 meters per second to the block. And then after, the block now moves at 0.7 meters per second. The bullet goes through at an unknown velocity, and the length of the block is unknown. All this is happening in the easterly direction. So now that we've got an understanding of the concept or the question, let's look at the questions that follow. 4.1 states the principle of conservation of momentum. So what does the principle of conservation of momentum state? Do you remember it? If you do remember it, it's time that you write it down. It states that the total momentum of a closed system is conserved or constant. Right? You must know this by now. Okay, so the block moves at 0.7 meters per second after the bullet emerges from it. The question 4.2 is asking us to calculate the magnitude of the velocity of the bullet immediately after it emerges from the block, right? What do we know? We know that according to conservation of linear momentum, right? Sum of initial momentum is equal to sum of final momentum. In other words, if I am to consider this bullet that we are given here, the mass of the bullet times the velocity of the bullet's initial, all right, plus mass of block, let's give it a different sign, times velocity of block initial is equal to mass of block times velocity final of block plus of bullet here, of block there. They are all B's. It can get all confusing. Big B is for the block, bullet, and small b is for the block. All right. So let's substitute what we are given within this particular question. All right. We are given mass of bullet as being 0.015 times the velocity before, which is 400, plus the mass of the bullet, the block, which is 2 kgs, and its initial velocity is 0, is equal to 0.001, there's 105 multiplied by VB final plus 2 times 0.7. Okay, so calculating the value of VBF will be a very simple equations calculation. We find out that the value is equal to 300 and 6,67, and this is velocity, so it should be in meters per second. Okay. In which direction? In the easterly direction. Okay, here they just want the magnitude, so we don't need to put the direction there. It's just asking us for the magnitude. All right. So that is the value of the VB. All right. I hope you have your calculators out, right, to do these calculations. Next question, 4.3. 4.3 is saying, if the bullet takes 0.02 seconds to travel through the block, calculate the length x of the block. So we want to find the length x of the block. Now, you can apply the laws of motion, which I am quite aware you have already been in use, or you have already used before in the previous grades, where you can use delta x is equal to, one of them is v final plus v initial divided by 2 multiplied by change in time. Okay? So we want to find the change in x there for the bullet. For the bullet, we know its final velocity is 400. Its final velocity is 306.67, right? Plus 3 so the 400 plus 306.67 divided by 2 times the change in time, which is 0.002. You must have your calculators out. Let's do the calculations. Stay. All right, so pull out your calculator and let's calculate the value of the change in x. Our value for change in x, if you have calculated it, is equal to 0.71 meters. One thing you must always understand in most questions in physical science that involve equation of motion is that it's not only one method that you use to find answers. You can use several methods to come up with the same answer or with the same value. Some of them can be longer routes, all right? Some of them can be shorter, like this one. So let's try out a longer route now of calculating the value of change in x here and see if we come up with the same value. All right. One of the longer routes that we can use is, because we have done the calculation of impulse by using F net times change in t equal to mass times change in v, or change in momentum. We can also apply the same in this particular question, where we will use our F net times change in t. F net, you know, is mass multiplied by acceleration, or multiplied by g. All right? And in this way, if we are finding an F net, okay, multiplied by change in t being equal to the mass times velocity final minus velocity initial, our value for the mass of the bullets has already been given to be 0,015, and the final velocity was 306, because we approximated it to 2 decimal places, okay, minus 400, which is the initial, divided by, if we now want to find the F net, change in time, our change in time, I'll substitute it quickly for you, 0,002. Our F net in this instance is minus 700. Now that we have found the value of our F net, we can use that equation, which I wanted to talk about earlier on, of F net equal to mass times acceleration, in order to find the acceleration of the bullet. Our effort is to try and find the length. So I said this is a longer method. We find the acceleration. After we find the acceleration, we can use another method using acceleration to find, using the laws of motion to find change in x. So let's see. Acceleration will be equal to 700. Mass of the bullets is 0,015 multiplied by a. So you can find the value of your acceleration, which, if you use your calculator quickly, divide 700 by 0,015, you would find a value of 46,666,67, okay, meters per second squared. Now you can apply this acceleration to any of the equations of motion that require usage of acceleration, initial velocity, and final velocity. All I wanted to do is to show you that this method can be used to find an F net, and an F net can be used to find acceleration. You can either use F net of the bullets or F net of the block itself, because you got those values with you. All right, so that's an interesting way of doing it, right? You can use delta x is equal to, according to your equations of motion, v initial multiplied by change in t plus half of acceleration multiplied by change in t squared, okay? And there you got your acceleration, you know your change in t, you got your initial velocity, you will come up with the same answer. That's a longer method of doing it. All right, let's look at another question quickly and find out more. Here is a question of Pat and Jabu, who are standing on a trolley. moving to the right at 3 meters per second, as shown in the diagram. Okay, here's another example of how questions on impulse and momentum can be given to you. All right, 3 meters per second, as shown below. What is happening? PET has a mass of 80 kgs and Jabu a mass of 65 kgs. The total mass of the trolley and the boys is 175 kg. Jabu jumps off the trolley or the skateboard at 3.5 meters per second in the direction of the motion of the trolley. When he lands on the ground, he falls forward. 5.1 says, name the law or the principle of physics which explains why he falls forward after landing on the ground. What law or principle would you think is applicable in this situation that he has to fall forward after landing on the ground? Think about it. Which laws have we done? He jumps off, but then he falls forward. Which direction was the trolley moving? It was moving forward. Does this ring a bell? The tendency of an object to oppose a change in motion. All right? Which is inertia, according to Newton's first law. Right? All right. 5.2 says, state the principle of conservation of linear momentum in words. We have done that already in my first example, where we said in a linear momentum, what really happens. You must be able to state that total linear momentum in a closed system is what? Is conserved or remains constant. Next question says, 5.3, calculates the magnitude and the direction of the velocity of the combination of PET and the trolley immediately after Jabu jumps off. This is a very simple question, all right? Because it's applying once again the aspects of momentum and conservation of momentum in essence. How are you going to go about it? You're going to simply say the sum of P initial is equal to the sum of P final. In this particular instance, we are saying because it's a combined mass at the beginning, mass of the boys, total, right, multiplied by the total velocity, because they are all together at this instance, is going to be equal, before is going to be equal to after, when they are separate. There are now two boys on it, on the trolley, and their velocity plus the mass and velocity of one of the boys final. All right? This is simply put as 175, that's their total mass, multiplied by 3 is equal to 110, which is the total mass of the one boy and the trolley, multiplied by the velocity final, which we are looking for, plus 65, which is the mass of Jabu times the final velocity of Jabu. If you got your calculator out, you can be able to see that the value of the velocity to the right is 2,7 meters per second to the right direction. Okay, which is in this direction. That's the final velocity that the total, the trolley and one of the boys continues with. All right, that's an excellent example that we can look at and think about in terms of momentum. The last question that I want you to look at is a question of a girl who's on roller skates. Is at rest on a smooth horizontal surface. The girl throws a parcel of mass 8 kgs horizontally to the right at a speed of 4 meters per second. Immediately after the parcel has been thrown, the girl roller skate combination moves at a speed of 0.6 meters per second. Ignore the effects of friction, right? The question says, define momentum in words. What do we know by momentum? We know momentum as the product of mass and velocity. Okay, good. 4.2. So we're looking at understanding the concept. Products of mass and velocity. That's momentum. Next one says, will the girl roller skate combination move to the right or to the left after the parcel has been thrown? Think about it. She's got a parcel in her hands. She throws off the parcel while on the roller skates. Is she going to move to the right or to the left? Yes, well done. She is going to move to the left. It is a law of physics, right? Which law of physics is that? That says when a force is applied, there's an equal but opposite force. That will be Newton's what? Third law. Okay? So she pushes off. Okay? According to the law of conservation of motion, again, we can think about it. If she's pushing off, Newton's third law is the one that talks about objects that are in contact. But now that she has thrown it and she's moving off the other direction, we can safely say that this is the law of conservation of linear motion. Perfect. Next question says, the total mass of the roller skates is 2 kgs. Find the mass of the girl. So, in this question, we are now looking for the mass of the girl. Again, we are applying the law of conservation of momentum in 4.3. Where momentum before is equal to momentum after. What is really happening here is that mass 1 times velocity 1 plus mass 2 times velocity 2 initial is equal to mass 2 times velocity 2 final Okay? Now, the first combination, we are referring it to the girl, M, and the parcel combination, we know the parcel is 2 kgs, all right, multiplied by 0 initially, plus the mass of the parcel, which is 8, multiplied by 0, and their final velocities is mass of the girl plus the parcel, okay, and multiplied by 0.6, and also plus 8 multiplied by 4, all right, which is the second combination. All right, so what we are looking for is the value of m. It becomes a very simple equation to solve here, where you would find that the mass of the trolley is 51.33 kilograms. All right. The question 4.4 goes on to say, calculate the magnitude of the impulse the girl roller skate combination is experiencing while the parcel is being thrown. What is the impulse? Impulse, as we know it, is equal to change in momentum. Change in momentum is mass, V final minus V initial, right? So, for the girl, we are calculating the value of mass, 51.33 kg, multiplied by the final velocity of the girl, which in this instance was, so that's the combination plus 2 times the V final, okay, the final velocity was 0.6 in the opposite direction, minus initial of 0, and your final answer there will be an impulse of 32 minus 32 Newton seconds. And in this case, they just need the magnitude without the direction. Therefore, impulse is equal to 32 Newton second. Okay. So that's the question. Without any further calculation, write down the change in momentum the parcel will experience if the girl experiences a momentum of an impulse of 32. What do you think the change in momentum of the object will be without calculation? Obviously, the change in momentum for 4.5 will be equal to 32 Newton seconds again. Newton seconds are the same as kilograms meters per second. All right, think about that and follow through the calculation of impulse. These are a bit longer questions that you needed to understand and work out. But as for now, momentum and impulse are done. It's ciao from Chibs.